I am sure you are all super excited for a second day of substitution. Yay. Good news is that the process doesn't change at all today. So we are just doing more with substitution to make sure we understand some of the more complex situations we might see. So let's say we are given the system 3x plus y equals 6 and 2x plus y equals negative 8. So if we want to solve this system by substitution, yesterday we said that our goal was to find the x or the y that said x equals or y equals and to circle it. Now you might be tempted to say, well, look, Mrs. McKinney, I could circle this right here. Well, if we circle that y equals, right, it's not by itself. So it doesn't really work to just circle it and say y equals. So instead, we're going to have to do some work to make it say y equals. And guess what? We'll have to use our skills for solving for y. I'm sure you are all super thrilled that we are going to be doing that again. So let's just say that we pick this top one. We have y by itself, but it doesn't completely say y equals yet. So we want to solve this for y. So to solve this for y, right, if we have 3x plus y equals 6, and we want to solve it for y, we will subtract 3x from each side. And so now we have y equals a negative 3x plus 6. Okay, so we won't want to use this one anymore, but instead we're going to use it now in its solved for y form. Now, some of my students will then say to me, well, Mrs. McKinney, wouldn't it also be really easy to solve that second equation for y as well? And my answer is absolutely. If that's the way that you want to go, feel free to solve them both for y. Maybe you want them both solved for y and you just set them both equal to each other. Just understand that solving them both for y isn't a solution that works all the time. So I'm not going to do that because that's not going to be something that works all the time. So while you're more than welcome to do that in examples where it does work, it's not going to be a permanent fix, okay? So now we have 2x plus y equals 8, and we have y equals negative 3x plus 6. So we can now circle this y, and we can underline what it equals. So what are we now going to substitute in for y in the top equation? We want to substitute in that negative 3x plus 6. So this y is leaving, and a negative 3x plus 6 is going in its place. So I now have 2x minus 3x, right? I could say plus a negative, plus 6 equals 8. Okay, the 2x and the 3x are on the same side, so I'm going to use the same sign to get them together. We will subtract the 6, so we'll have negative 1x equals 2. Divide by negative 1, and we are going to run out of space here quickly. So this tells me that my x value is negative 2. But remember, I am still not done. I never said these problems were short, right? I have the x value, but to solve a system, I need the x and the y. So I need to take this x value and I need to plug it back in where we underlined. Again, you could plug it in to the original equations over here if you wanted. It's just easier where we underline. Okay, so now we're going to say y equals negative 3 times negative 2 plus 6. So let's see, negative 3 times negative 6 plus 6. So we will get y equals 12. Okay, so negative 2 comma 12 is our solution, or x equals negative 2, and y equals positive 12. So let's take a look here at another example. 3y plus 4x equals 14, and negative 2x plus y equals negative 3. So if we look here, what do we think might be the best equation to solve for? Yeah, let's pick this second equation. It's going to be pretty easy to solve for y here. We have that nice and neatly solved. Okay, not solved, the y is by itself. Okay, doesn't have a coefficient or anything else with it, so it's going to be pretty easy. Okay, so now we have a 3y plus 4x equals 14, and we have a y equals 2x minus 3. Okay, so here is my y equals, and here's what it equals 2x minus 3. What variable do I want to substitute in for on that top equation? We want to substitute in for y. Now, we're just crossing out the y. We are not crossing out that 3. And in its place is going a 2x minus 3. So we now have an equation that says 3 times 2x minus 3 plus 4x equals 14. So let's go ahead and start solving this. We'll distribute 6x minus 9 plus 4x equals 14. Again, this part, while it's work, should be easy work. Should almost just be solving these with little thought at all. Okay, and here's where my students go, Mrs. McGinney, I definitely can't solve this. That's not nice and pretty. That's okay. The reason why we often have to solve by substitution and not graphing is because we don't get integer values. Instead, we get rational numbers like decimals and fractions. So you can decide however you want to work with this. Just remember the rule is no approximating. So if you want to leave this as 23 over 10, that's totally fine. However, this is a number we have to substitute back in, and knowing the majority of my students, you're all probably going to want to turn this into 2.3. Again, I don't care as long as you are not rounding. So understand if that was a repeating decimal or something, don't round. You would not be able to plug back in a repeating decimal. And so you might just have to deal with that fraction all the way through. Okay, so this tells us that our x value is a 2.3. Because I just want to show you that it can be done as a fraction, I'm going to leave it as 23 over 10, even though most of you would not. And you can all be grumpy at me. Okay, and I'm going to take this and I'm going to plug this in for x. So I now have y equals 2 times 23 over 10 minus 3. Even if you say you hate the fractions, remember, we know how to type these in our calculator. So you could do 2 times and then do 23 ABC 10. Okay, and then subtract off the 3. It gives us a 1 3/5. Okay, so we get 1 3/5, which would be the same thing as 8/5. Or let's see, for you decimal lovers, a 1.6. As long as you are not rounding, I do not care. Let's look at one final example here. Let's say we have 2y plus x equals 4 and a 3.5x plus 7y equals 14. Well, we don't have anything that has just a y with no coefficient in front of it. So this one we kind of got to go a little bit off our norm, and we're going to solve this for an x. Now, if you did choose this y here or this y here, right, you'd be dividing through. We already got this 3.5 going on. Oh, that's going to be all types of crazy. So you could do it. You're not going to be very happy. So let's solve this first one for x. Let me try that again. Okay, so we have 2y plus x equals 4. If I want to get x by itself, I'm just subtracting that 2y. There's no coefficient in front of the x, so it's no big deal. There's no other steps. Okay, then I have a 3.5x plus 7y equals 14. And for all of you being decimal lovers, you're still going to be grumpy that this has a decimal in it, but we're going to treat it all the same. So here's where it says x equals, and here's what it equals. Okay, which of the following equations is the correct substitution? We want it plugged in here, right? So we want 3.5 times negative 2y plus 4 plus 7y equals 14. I kind of squeezed that in there. Okay, so we're going to do 3.5 times negative 2, which gives us a negative 7y. Then we're going to do a 3.5 times a 4, which is going to give us a 14. Plus 7y equals 14. These variables are on the same side, so I'm going to use the same sign. So those cancel each other out. And I get 14 equals 14. This is a true statement. So what do we think our answer is going to be? So this one was kind of a trick one. We have to pick infinite many solutions because this is a system. If you picked all solutions, that would be correct for an equation. But remember, with the system, we don't ever have all solutions. This would be where the two lines overlap, and there would be so many answers we couldn't write them down, but it wouldn't include everywhere on the coordinate plane.